Alright, I don't want to waste your guys' time. Let's just get straight into it. So, starting off, one kind of pattern you can recognize is this positive and negative, right? Some of these derivatives are positive and some of them are negative. And you might see that if the original function starts with cosecant, cosine, cotangent, then you're going to have a negative as your derivative. Sorry, let me erase that, and then here you go. So cosine, negative sine, cotangent, negative cosecant squared, and then cosecant is negative cosecant cotangent. Okay, so that's one big initial pattern here, and that's going to help us with actually all our functions, because the ones that aren't cofunctions then must be positive. And we're going to kind of look at each of these pairs if you see the arrows I drew between them kind of in more depth. So between sine and cosine, I find that the best way to remember this is that they're opposites. Okay. So what does this mean? So this means in this pair, each derivative is the other. And I worded that kind of weirdly, but all that's to say is sine is cosine and cosine is sine. The derivative of sine is cosine and the derivative of cosine is sine, but remember it's a cofunction. So actually it's negative sine. Okay, cool. That was pretty quick. I think that makes a lot of sense. It's pretty easy to remember. So we're going to move on to the harder pair, which is cosecant and secant. So starting off, we're going to say, okay, cosecant, secant. Each of the derivatives starts out with that. So the derivative of cosecant starts out with cosecant. The derivative of secant starts out with secant. So starts out same. Okay, starts out same. Now, the second part, we're going to actually jump around here a little bit. So the cotangent part, we're going to associate this negative with cotangent. And we're going to associate the positive with tangent. But if we jump down here to this bottom part, we're also going to realize that the negative here is also associated with this cosine, this cofunction, right? So the pattern here is it's a cofunction, so it's negative, but that also means that this term is also, both of them are also going to be cofunctions. So cofunction, negative cofunction, right? Cosecant means it's negative, and both of the derivative terms are going to be cofunctions. And same thing if we jump down here to cotangent, it's going to be negative, but that term is also going to be a cofunction. So it's going to start out the same. Sorry, to get back to this pair right here, it's going to start out the same, and then you're going to apply these patterns of, okay, it's negative, it's going to be cofunctions, and then in contrast, it's going to be secant tangent, and that tangent is not going to be a cofunction. Okay, so finally, for this last pair, one of the kind of patterns here too is that it breaks the pattern, right? Both of these are squared, and none of the other derivatives are squared. So we'll start with that, and then remember this association, this negative and becomes a cofunction and a cofunction in the derivative, and in the initial function that's also a cofunction. So in contrast here, tangent, not a cofunction, so it's not negative and it's not a cofunction. Now, this tangent makes me want to go on a tangent real quick, if that is a good pun. But one way you can remember this, all of this, I'll start writing up here, is to see the proof of this, or prove the proof. See or prove. I'll write that there. See or prove the proof. Okay, so when you see, or if you actually end up proving the proof, what we're kind of trying to build here is a deeper understanding of the math, and that's going to help it stick in your head better. You're going to do deeper processing, and then you kind of work your way up into a bit more shallow of processing when we do this pattern recognition that we're doing right now. Okay, pattern recognition. And it's a bit more structural, but it'll also help cement these. It'll give you some memory cues to go off of. You'll see sine and you'll think, oh yeah, it's going to be opposite, so cosine. Or, oh, tangent, it's going to be squared, and it's positive, so secant squared, right? And finally, to kind of pull it all together, you're going to use some flashcards. Okay? And flashcards will just help you, like, get it much quicker and really help make sure you have it down. So on top of understanding the underlying math and on top of having memory keys from the patterns, you'll have rehearsed it enough that it'll make sense. And really, I think if you've done the proofs and you've done the pattern recognition, truly you don't need much flashcards because you should already understand a lot of the logic here behind them. Or if not the logic, at least the pattern. So that hopefully should keep you satisfied and help you remember it for as long as you need.